welcome everyone to the Tesla D event. There's been a lot of speculation as to what the D stands for. Yes, well, you'll notice my pants have Velcro seams. They may have mixed appeal. And there's also a great deal of speculation as to what the something else was. And I learned a lot, including things that I didn't think were physically possible. Let's go to the first D. As you've probably learned by the internet, since it's impossible to keep anything private these days, the D stands for dual motor. So let's bring up this slide. So there you can see you've got a motor in the front and a motor in the back, hence the dual nature of it. But what would be greater than sort of seeing a slide is to show you the actual car. So let's release the Titan. So here we have the chassis and the drivetrain of the dual motor Model S. Obviously got the front drive unit, the rear drive unit, and the thing that makes this unique and special and sort of better than all-wheel drive in the past is because you can dynamically shift the power from front to rear at the millisecond level. So you can very quickly adjust torque more than is possible really with a mechanically linked system. So all all-wheel drive systems out there are just mechanically linked with a shaft. So it's like the equivalent of being sort of analog, whereas this is a digital system. So with a system like this, it's inherently able to achieve better road holding than a mechanically linked system that's just there with a single engine. And we're able to actually improve almost everything about the car, it's a rare case that you're able to do something like that. So the acceleration gets a little faster, the top speed is higher, and something that's I think that is for the first time ever, the range, the efficiency actually increases. Okay, so. As you probably know, with all all-wheel drive systems out there, you get less mileage. It's less efficient to have an all-wheel drive system. But in the case of the Model S, because we're able to have two drive units where we can shift the power from front to rear and constantly be at the optimal efficiency point for each motor, we're actually able to overcome the penalty of the increased mass of the motor. So any given motor or engine has a power versus efficiency curve, and the default behavior of the car will be, the first priority, of course, will be traction control, road holding, and then the second will be efficiency, and then as soon as you punch the accelerator, it'll just go to max power. And efficiency, obviously, is less of a concern in that situation. But literally everything improves about the car with dual motor. There's no sort of technical drawback in this case. We've also in the highest power version, the P85D, we've actually retained the larger rear motor and added the medium-sized motor to the front, which basically gives the car about half again as much power. Because the P85 started was pretty good, on the power front. As probably a bunch of you have those cars, but this car is nuts. It's like taking off from a carrier deck. It's just bananas. It's like having your own personal roller coaster that you can just use at any time. So that it's really mind blowing. In fact, the target that we had for performance was to try to meet one of the greatest. The acceleration of one of the greatest supercars of all time, which is the McLaren F1. And so we were able to actually achieve a 3.2 seconds 0 to 60. Yeah, it's mad. Okay. In fact, just we're going to have an option in the option selection. You'll be able to choose 3 settings, which is normal, sport, and insane. It will actually say insane. It's true. So that's it's pretty exciting. We're really proud of what our engineering team has been able to accomplish here. It took a lot of effort, and I think we've got a technical solution we can be really proud of. And it's also one that will continue to improve over time. So as we'll roll out the initial cars with dual motor, but then we'll keep updating the software and firmware and improving, for instance, the torque vectoring and the road holding under various circumstances. So it'll keep improving by nuances over time. All right, so let's move to the something else, which. So we've been able to accelerate Autopilot and bring it to market faster than originally anticipated. In fact, what people haven't quite realized is that all cars produced for the past 2 weeks have the Autopilot hardware. So it's actually in production. In fact, every car coming off the line in Tesla at the factory has the Autopilot hardware. So let's look at the various elements of how we're doing Autopilot. It consists of a synthesis of 4 different systems. The first is a forward-looking radar. So that's scanning the cars in front of you, and it's quite long range. So it's able to see things at a long distance. It's also able to see through fog, through snow, through sand, through anything, basically. All right, moving on to the A. So it consists of 4 parts. The first part is the long-range radar, which can see through basically anything. And then the next element is a camera with image recognition, so it's able to read stop signs, distinguish pedestrians, look at traffic lights, and also serve as a backup system to the radar. The third system is 360-degree long-range ultrasonic sonar. So this basically establishes a protective cocoon around the vehicle, and it will attempt to make whatever the sort of smart move is from a safety standpoint, looking at the ultrasonics. Now, the good thing about the ultrasonics is they can see even soft objects. So they can see a sort of a small child or even a dog. They're very sensitive, and they operate at all speeds. So you're able to do this from 0 miles an hour to 155 miles an hour. And so it'll detect if there's a car in your blind spot, if you've got a highway barrier on one side, if there's something you might move into in any way possible. And then the final element is integrating that with navigation and basically the GPS system and real-time traffic. So we integrate those 4 systems in. The car can do almost anything. So we're able to obviously do lane keeping on freeways, do automatic cruise control, active emergency braking, so that it'll brake if it sees any object that you're going to collide with, and it'll self-park, so you'll be automatic parallel parking, automatically go into a garage. In fact, when you get home, you'll actually be able to just step out of the car and have it park itself in your garage, including it'll open the door, and it'll go in and park itself. And then something I'd like to do, which I think many of our engineers will be hearing this in real time, is have the charge connector plug itself in. like an articulating, like a sort of a snake, like Metal Gear Solid or something. Yeah, like just plug itself in. So I think we'll probably do something like that. So you can just get out of your car and go park itself in your garage. And then going a step further, you'll be able to summon the car if you're on private property, because you have to be on private property for this. You can actually summon the car, and the car will come to wherever you are, and it'll use the ultrasonic sensors, kind of like a insect antenna, because it can detect even small soft objects with the ultrasonics, and just it'll sort of slowly make its way to you and then stop and be ready to go. It can actually go even a step beyond that, which is if you have your calendar turned on, it'll meet you there. Okay. And so if you're getting ready to go to work for something and it knows, oh, you're going to need to leave half an hour before work, you can say, okay, I'd like it to just come out and have the air conditioning done and everything done, your music playing, everything's just ready to go, and it'll just come and be there. So. A very important point, though, in addition to the sensors, you have to have precise control. So we have an all-digital control system, high precision, really low latency control system, starting with the motors. Obviously, they're electric motors. They don't have the latency and the sort of slow spool up of gasoline engines. Then we go to the brakes. So one of the big upgrades to the car is an electromechanical braking system. So this is one of the most advanced braking systems in the world. It's able to very precisely control the amount of braking and also get to high braking levels very, very quickly. Instead of having the normal vacuum assist system, this is an electromechanical system. And then we've got that's combined with an electric steering, so it's electric power steering. So the whole system is sort of fully electric digital control, low latency. This is all really important to having a great driving experience, so that the car is doing things in a natural way. All right, next one. So this gives you a sense of the new interface, and you can actually sort of see where cars or obstacles are around the car on the instrument panel. So it'll actually show cars that are, the distance of the car ahead of you, cars moving to the sides and behind, and you can adjust the sensitivity of the autopilot. So do you want to be in a sort of an aggressive autopilot or less aggressive? Yeah, so it'll warn you with sort of with initially a visual warning if there's a potential collision risk, so it'll turn the object red. And then it'll give you an audible warning if you don't see that, and of course it'll resist steering into things that it thinks are danger. So you can still overpower the steering, but it's going to give you a tactile feedback that you're probably headed towards something that the car thinks may be dangerous. So that's what we have for you tonight. But I mean, my words are nothing compared to the car. So. We've got a whole bunch of cars ready for you to take a test ride in, and I think you're really going to enjoy it. This is like an amusement park ride, and just to sort of tone it down, you'll see what the car's like with anywhere from 3 to 5 people in it. Imagine if it was only you. It's that much. It's a lot faster. So have a great evening and enjoy the test drives.